Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. Now the music is all stuttery because when I click away from it to go and unmute it in OBS, the thing pauses. Because RetroArch is a better front end than the CLI one that we have. Oh darn us for doing a good job and integrating with this. Shame on us. By the way, hi to guys in the chat. MS Visser, Mad Moose, SK Thess, Def Param, H Corian, Desi Used, Freefall, Pyro ESP. Yeah, so I mean, we've just been chugging along with this Libretro implementation, and it's going, I think, pretty well. See, there goes the audio again. Does that even say? Oh, yeah. Anyway. So mostly what we've been doing is working on reducing allocations and copies in the AV output chain and supporting all the pixel formats. The only reason I haven't checked this yet is because I still want to do this for audio. We did this for visuals, where we can basically, we refactored the sync so that we pass in an existing buffer to the emulator that it fills up, maybe, as it's running. And we need to do the same thing for audio. The audio sync is probably going to work a little bit differently, but not too much differently. And I think we'll do that today. I don't know how long I'm going to stream today, by the way. I think maybe not that long, but we'll see. Hey, Dark Second. Oh, I still love watching this thing run. This game has one of my favorite demo modes on the system. It's just satisfying. Okay. Dead. Now then. I haven't looked at this since last stream. Can you tell? All right, so I think we'll just start in here. So currently I think we just have these sync and syncref types, and then I just use a sync of audio frames, and it ends up just being a vector currently. I want to change that a little bit. Hey, nice chicken, Mishka. I think generally all this goes away, actually. I mean, maybe we still want to have function calls for this, but I'd rather get rid of them because we don't need them. I think it'd be faster without them. And we'll just have a vector of audio frames that the thing just knows how to append into. Yeah. So then this will, of course, break things, but I want to see where it breaks stuff. So I'll run it. Right, so that's where we expected. It's on the top level stuff. There's no sync. Not too bad, actually. Yes, I'm thinking that because we have a video sync here, and we're probably going to have a audio sync. And this also will probably do this, because we'll have a buffer, which is going to be a, like, we don't have different formats here, so really it's just going to be a reference, mutable reference to a bunch of audio frames. So here the buffer was like, you would only have one frame buffer that you would fill in. Here our buffer is going to be a buffer that we append to. Be something like this. I still really need to check out Visual Studio Code. I've just been super lazy about that stuff. Also, I just haven't enjoyed the editor previously, so I'm not that motivated to do it yet. But anyway, I kind of don't like this because it makes the emulator have to care about making sure this is in bounds. I guess we'll get extra bounds checking from Rust, and so that's probably not too bad. And this will definitely be the fastest way to do this because we can do like bulk updates. We could just do several samples into the buffer and then increment the position. So I think this is actually probably our best move. And either way, I'm not too hurt by this design. Even if it may not be the most rusty thing in the world. I don't really mind. Yeah, I think I'm happy enough with this. And so then this should be really easy to change. This part no longer uses syncs. It'll just have an, or actually it does do that. Yeah, like that. Where were the other ones? Interconnect here. And then VSU is going to be where the other one was. I mean, I guess the other one could have worked too if we had just some buffer and we made that generic, but I don't think that's a problem. Ledev, thanks for the follow. Hello, Lexemtex. I don't mind not having this generic because the different kinds of syncs are different anyway, and we can always make them generic later. So I think that's fine. And then this should only be a problem, at least for the Libretro front end, where this is used, which is down here, append. Yeah, put. Basically that. And so then we just need to make sure that the sync itself, the buffer is always big enough to store these samples, which shouldn't be at all an issue. Like if we make it, I like to make these too long as well, because it doesn't really matter that we allocate a bit more memory if we never touch it. So I think what we'll end up doing here, first of all, I'm just going to hook this up again so that the Libretro front end works. Like as is, even though it's outputting a sample at a time, and then we'll change the actual output that we use there. Yeah, because one of the main things I want to avoid is calling functions for every sample that we output, because I don't believe that that's actually going to get inlined, especially through a trait like this. unless we made the emulator generic over the syncs. But I think just having a design that doesn't make the compiler have to jump through a bunch of hoops to be fast is not that bad. Anyway, this will be audio sync. I mean, we don't really need to imp to have this in the first place, actually, because we're just going to make the buffer. Let's do it down here. And we can do... We'll just do this first, and then we'll make the buffer persist after. Do it like that. And here we'll do the initial value, which is going to be 0, 0. Should be fine. I think it's I16, I16 is the type. Yeah, that's what it should be. And then this will just do... I mean, I don't know how many we need. What I want to do, I think we have the sample rate. We have this. So this would be 1 second of audio if we did the sample rate. And that's going to be way more than 1 frame. Is it tone 17? Thanks for the follow. No idea how to read that right, but hopefully that works. So we know it's also 50 frames a second, so we could do this. But what I want to do is this. Yeah, I think that's fine. And then... Nice. So where were our callbacks? Onyx Z, thanks for the follow. Lots of follows today. Appreciate that. So instead of calling the audio sample thing, we're going to call audio sample batch. Now I need to look up the API really quick because I need to be sure about this frames. I expect that to be the amount of frames, considering it's called frames. Yeah, that is what it is. So we already have this right then, and then we just need to call this at the end here. Whoops. So then this should be a U size. And that should work. And then here, I'll do this. I'll get to those errors in a sec. Oh, and I know why this isn't working. Whoops. Oh, I keep moving between files here. That's where I wanted that. And then we can do this. What do we do for this? Yeah, because I pull it out of there. This was as mute pointer is what I want to call in here. Something like that. And then we want to pass this going out there. And for the amount of frames, we can just use the position. And we'll do that just in case the size T doesn't match. It should match, but just in case. Well, looks good. Let's see if the compiler yells at me. And it does. Yeah, we want this, first of all. This, couple things here. Yeah, first of all, that should be a semicolon so that we get the initial value in this. Okay, we'll do that then. And we can just cast this. And then it doesn't like the borrow. We can just make a scope here. Now we need to pull this out of the sync, so we'll do this. Or I'll call this rendered audio frames. Sounds good to me. And then we can do this. And then we can return audio output sync dot buffer position. Well, it built. Now we'll see if the audio is messed up. Probably isn't. Seems fine to me. I feel like I'm hearing more ringing than we had before. So let's compare. Get status is my favorite, you guys. Yeah, I think I was just hearing things. Actually sounds fine comparing side by side. I think we're good. Need to test with a better sounding ROM, of course. Soundtrack in this game is awesome. Someday I'll fix that timer. I love this soundtrack. Are you guys not getting audio? Oh, sorry about that. Is that fixed? I don't know how I muted that. Oh well. You just have to take my word for it that it sounded the same before and after. All right, we're done. See you guys later. Nah, I'm just kidding. So this is pretty good, but we definitely want to not reallocate this buffer. I think we already have. Yeah, here's our video output frame buffer. Make an audio output buffer as well. And this is going to be a vec of audio frame. Adur to dur. Thanks for the follow. I'll just move that, and then this should yell at me. That should be it. It shouldn't matter that we're using the same buffer, because we always tell it how many frames of that to actually use. Now, at some point, I still need to fix up our command line front end with all these changes, but I wanted to make it work under the constraints of Libretro first to make sure that we covered all those cases. Because it'll be easy to backport it to the other stuff. Oh, this feels good. And no audio test for the Virtual Boy would be complete without Waterworld. Hey, Little Bits, thanks for the sub. I know you've subbed before, but I'm gonna say thanks anyway because I still appreciate it. Also, hi. How neat is that? This soundtrack's awesome. Oh yeah, 4 months. High score. Can you guys hear the music okay? I feel like I should turn it up. Yeah. I still think Rush Boy is the only emulator that plays this song correctly, at least the correct speed. I know at least Midnafin plays it too slowly because their timer interval is wrong. And the really obvious way to check that's correct, first of all, I've tested this on hardware and it's totally the case. But the other reason why it's really obvious that this is the correct rate is all the other ports of this game play at this rate as well. Like the Super Nintendo version, for example. Yeah, Ocean did have a lot of great tracks. Too bad this game is complete crap. And I hear the movie's not much better. But the soundtrack's awesome. So. Oop, I don't like it when I get these. Yeah, that took a half an hour. Man, I hope you guys aren't hearing my Slack stuff. I should sign out of that. All right. So with that, we have totally used buffered audio output, first of all. And second of all, we've done this. We've reduced the allocations of the copies in the AV output chain. Now we support getting buffers from Libretro, from the host, or we only have our output buffers that stick around. Can you actually see the work notifications from Slack? No, you can't. That's not on my screen, is it? Oh well. Okay, that makes more sense. It's one of the reasons I stream my top right corner of my screen. Anyway. Yeah, so we've done this, and then our output chain is at least doesn't do any copies. Or as few as it needs to. I know that at least in RetroArch as it is now, it actually doesn't support that thing where it gives us a frame buffered output in. So we have a copy there, and I'm pretty sure we're going to have a copy in the audio output as well. But at least up until that chain, we do 0 copies, which is pretty cool. So that feels good. Now, we have a lot of things that we can still do. Might as well just pick one of these. Now, getting the stuff on the CI pipeline, I don't want to do yet, because first of all, it's going to be a pain in the ass. Second of all, I don't want to do that until things are more done. Support multiple stereo output options. I also don't want to do that yet. I would like to do some of the other things first. Revisit controller input Impl to see if we actually need to map analog sticks like we do. This one might be a good one to look into now. We also have profiling and benchmarking, which I'm just not up for today. SRAM could be really interesting, actually. In fact, this is one of the ones I want to do pretty quick here. Maybe I'll do this one next, actually. We also have serialization, deserialization. Now, it would be trivial if we just... I know, right? SKTS? I'm ruining the curve for everyone else. Just like school again. Except I never tried in school. But anyway. Serialization, deserialization. The thing here is that we could just use like Surday or something. But I actually don't want to do that. I want to do this explicitly. And the reason is that I wanna have these things versioned. So all of the save states I really want to be tied to a specific version. Or like have different versions of the save state formats. And the reason is because I want to have as much internal information in those save states as possible. And I know that at least like in the timer, I know that there's bugs. So I would like to be able to fix bugs and then still have old save states work. And I'm worried that if I do like SRD or something, then it wouldn't work. Yeah, so exactly freefall. So I could absolutely do that where I use, separate structs and then use SRD to serialize and deserialize those other structs, but then I want to have those structs be versioned. But I think that wouldn't be too bad. Because another thing that you can do, I've thought a bit about this, is we could have separate structs for each version, and I could just fork those every time we do a new save state version, and that's not really that bad. Like those grow, but it's not really an issue. Because then we can detect the version and then deserialize into those states, and then every time you introduce a version, all you have to do is make a mapping from the previous version to the current one. And then you can always support all the way back because you can always just go through several conversions till you get to the latest one. And I don't think we'll have that many versions because I'm not fixing these kind of bugs that terribly often these days. Things are getting pretty solid here. So that would be really nice. And there are certain things that probably wouldn't even change when bugs are fixed. Like there's some timing things where it wouldn't change that. It's just whenever the state would change. So I don't think it would be that bad, but it's something I want to think about. There's updating the cargo file. That one's pretty easy. But again, I'll wait until everything is more or less done here. But I kind of want to look at SRAM, because SRAM wouldn't change between versions. This would just work. So I'm thinking this would be a good one to do next. Plus, I think all we have to do here is just implement some Libretro entry points. And then we just have that, which is nice. So I think they just call it memory in the Libretro API. Just looking through this here. I see this retro get memory thing. The nice thing, by the way, about serialization and save states is that the API just asks for, some data and a size. So we could serialize this. I'm thinking in a human readable format because there shouldn't actually be that much state. I'm more concerned with compatibility and being able to see this, obviously. It depends, though. We'll have to look at some things. I always really liked bson, if you guys have heard of that. I know it's used in MongoDB, but it's a binary version of JSON, basically. And what I always liked about it is that you could still make extensible structures with it in the same way that you could extend JSON, but then it's also implemented in binary, so or bson, I guess you would say it. But I always liked that because you could always, like, it's very easy to just deserialize this into a simple tree structure, or serialize to a simple tree structure and then save it out as bson. Just certain things like that I want to be stored with binary container formats, but I want the container format to have extensible and optional fields and stuff, and it just is way easier to do that than just do some like hard-coded offsets in a struct. So I think that's pretty cool. Exactly, it's crying like Daniel-san. Oh, I love that movie. Cheesy as hell, but I love it. So I think what we do. Oh, this is actually kind of cool. That we can also expose things for different kinds of RAM. That's kind of cool, actually. Because you could have front ends that actually look at this stuff. That's kind of neat. Because then I guess get memory data and stuff probably take this memory mask. Yeah, this ID here. That's actually really cool. I'm going to add something here. I don't know if I want to do that, but I want to write down that it's capable of doing that. Yeah, I think so, Darkside. I don't know if it's writable, though. I don't know that. Because that's going to make a difference in terms of how we implement it. We don't care about this system directory stuff. Here's some descriptors. Hey, Metal Voids. Did I say hi, Chief Detector? I think I did. I wonder if I'm supposed to return these memory descriptors. You can only do that if you return a proper memory map. Subsystem memory info. Is that what that one was? No, that was just this. The extension and the type. Right, so we just return a list of the ones that are supported here. So it looks like we just have these descriptors here, which type they are, and they can get at the memory. And I'm going to assume that those are supposed to be read-only. And then if we do that memory map API, that would actually allow it to write to those and do cheats, which I'm not that concerned about, at least not right now. Then again, it does say expose all relevant pointers. So maybe that is actually something that we need to, maybe we do actually give the actual memory. I was thinking to copy it out into a buffer and then yield the buffer, but maybe doing it as pointers is actually the better way to do that. Then we can just map the same memory that we have. It's definitely not safe, but I don't think it's that bad. Can't imagine the front end doing that much with it at the moment. And there was that thing too about the descriptor, although I don't think that was, where was it again? That's the memory map descriptor. The subsystem memory info. Okay, yeah, this is just an extension of types. This doesn't mention anything about mutability. Only the memory map thing does. Let's just give it the pointers of our actual data, and that'll be fine. Or we hope it's fine. Probably okay. So then what we need to do is in ROM info, we need to return these amount of memories. So I know it gets us somewhere. The system info thing. Wait, was this the right descriptor even? Because we have this get system info thing. So now I'm actually thinking. So it must be calling these memory size and memory data. But it doesn't seem to call the subsystem thing because I don't see it listed here. I only listed the functions that I knew that the thing would actually call. So it must just be calling these anyway. We can try this. Let's just see what it's doing. Maybe do this. Yeah, you can see here. He was trying to get, system RAM, save RAM, video RAM, RTC, all that stuff. Also call it with 0 a bunch of times. What's the deal with that? Okay, so save RAM is 0. RTC, system RAM, video RAM. So 0, 1, 2, 3, and that should be all we see. And then it decided to do RTC another time. Which is probably fine. And I'm guessing it's not doing the data callbacks. That might be, but at least we're not seeing them here. Well, I didn't print them, but yeah. Probably doesn't do anything with those because the sizes are 0. So yeah, I guess we'll just start implementing this. So I want to make sure that I have these constants available, first of all. I meant to put them in here, but a lot of things ended up in this callback thing, so I just want to make sure I didn't have this elsewhere as well. Probably don't, though. Yeah, I'll stick them in here. Probably want this too. Now, I don't prefix these with retro in this particular module because it's already called retro. So that's kind of neat. Write them in hex because I'm cool. So what we should be able to do then is this. Let's do a catch-all first of all. I think the only one we'll actually support first is just SRAM. Now this will actually change potentially throughout. And hopefully the front end is going to know that. Because the way that we've implemented the SRAM currently is we actually only expose how much memory has been used. Now I think, yeah, I do actually the max SRAM size. It probably wouldn't hurt to just do that, considering I will always have that buffer available. And I already have the pointer here. I do that for speed in a lot of places where it's just these really simple buffers. Because that did actually show up when I profiled this at one point. So I might as well do that. Oxidao 2, how's it going? And again, I just want to have a lot of these just in case those don't match up. Not any no released Virtual Boy cartridges have custom hardware in them, as far as I know, other than some that had SRAM. And this max SRAM size, that's as much as is mapped. So if it had to have more than that, it would have to bank switch or something anyway. Oh, cool, Oxidao. I've never heard of that person. But I'm kind of curious what they said about me now. It's kind of cool. Anyway, I think that's good here. And then we need to make sure that if we're returning a non-zero size, we better also be... Oh, whoops, that's serialized size. We better also be actually returning the proper pointer. So in the default case, we'll just do null mute again. And then here, I want to do a couple things. First of all, I also want to see where this is. Loads the content file. So I wonder, it probably has everything loaded here. The issue is that I may not actually have a valid system available yet when the game's not up, but I'm gonna just try it, assuming that our context will have a system that's constructed. Otherwise, it's gonna have issues. And we'll find out if that's the case. So this will be something like... context.system. I think unwrap is going to take ownership. We can do as ref unwrap. Let's do that. And then that'll be dot Virtual Boy, and we'll follow it from there. Interconnect.sram. Yeah, I don't think I have any of this exposed. For good reason, because I don't want this to be read or written to directly. But let's just do this. Ah, cool, Oxidao. That's awesome. Yeah, that's exactly what that is, Oxidao. What I'm working on right now is implementing a particular C API for an emulator that I have. So yeah, that's exactly what that is. So yeah, that's ID here. And this, we probably need to cast this pointer. Whoops. So let me remember how to type. And that should do that, actually. So, Oxidad, thanks for the follow. Do I have this running? Really? And I do. All right, so let's run this again. Let's do whoops, what happened to my stuff here? There we go. I know that Wario Land, for example, has SRAM. All right, so here, this is kind of cool. Here it got the data. I don't know what these are. I wonder if these are hashes or something. Maybe they're the pointers, actually. And it's that much memory. It failed to open the SRAM notice file directory. That's to be expected. So it did skip SRAM load. That'll be interesting, actually, to see if it just loads the memory in there or not. We'll see. We'll see. Yeah, I'm guessing a lot of these dots here is they have some dot at the end of all the output things or something, and then some of the other ones they also do dots. We're gonna do this. I'm just gonna skip all this stuff. Oh, now I'm paused. I'm just gonna hit escape. And I want to see something here. Okay, so it did actually save an SRAM. So let's just run this again and see what happens. It didn't crash. So up here, it did say skipping SRAM load. I wonder why that is. But there's my file, so something worked. I don't know why it says skipping that, because it clearly got the save RAM. That's cool, by the way. Also, I think... what did it say? Yeah, so it said redirecting the save file to this. RetroArch saves SRM. I think this worked. I think we're done with this. That's pretty cool. Let's do... I don't actually know which other of these games have save RAMs. Actually, I do, because they're all that SRM here. You just pick one. Let's do Taylor Boxer. Actually, does Toby Das say? No, that doesn't. Let's do Taylor Boxer then, because this game's actually fun. Yeah, this was really easy. And I might as well expose the other RAM types just because it was so easy. Even though I don't know if we can test them in this front end. Now, the thing that I don't like is I don't necessarily want to have those fields of that structure public, but it shouldn't really hurt. Wait. You see that? It just knew my controller was plugged in. Does it work? Looks like it works. That's pretty sick. I'm gonna fight Johnny here. see if the triggers work for this. Those are oh, nice. That one works. This one doesn't seem to. Oh yeah, it does. Cool. Oh, believe me, I've thought about it, Dark Second. I have another teensy, so I should be able to do it. I'm not good at this game, by the way. Also, these inputs don't seem that responsive. I don't know which part of the emulator and/or front end is at fault there. But I don't need to get very far here. I just need to get far enough that it saves this. No timeout. Run over, take a break. I don't really know how to block here either. I'm just gonna... Exactly, Pyro. I'm just gonna button mash until he dies. Play the next game. I just want to see that my save file's still there. And it is. So now I want to close. Just open it again. Yes, I also have an N64 hooked up to this. Although I don't think it's mapped currently. Yeah, there's my save data. It works! Like I said, I might as well do the other data too. Because why not? Wasn't like this was particularly difficult. Now the RTC... I guess we could use the timer state for that, but I'd rather not. We'll skip that one. And then we'll do system RAM and video RAM, because I know we have those. This will be the WRAM bytes pointer as pointer mute that. Now, remember, it's totally unsafe, but it was easy. Assuming the front end is sensible is kind of a good thing to do. Also, I know I don't expose the bytes pointer there yet, but I'm just gonna do it as if we do and then fix it up in a minute. And then video memory, it's gonna do the same stuff. And this will be VPU, and we'll have to see what that is. Or VIP. And this is gonna have a VRAM pointer. Make that public here because I know we're going to need it. Again, I may expose these differently, stick them behind a callback or something. At least that guarantees their only read, or that would guarantee their read only. And then the system RAM I know is 64K. Hard coding values in this case is totally fine by me, by the way, because it is. Like, because they never changed. The only reason that would ever change is if the system changed, and that's not going to happen unless someone makes a time machine, in which case the emulator probably would be correct. No kidding, Dark Second. Interconnect is private? But this worked. Oh, WRAM is private and VIP is private. That makes sense. I think I have a lot of stuff on here that is... Like, the SRAM is probably public because the command line interface saved that out. And a lot of this I just don't make public until I need to. Serialization, I'm guessing, would also make a lot of this public. Because I like to have serialization where it introspects a tree of objects. I don't like to defer... I don't like to do the ouput approach and defer serialization to the objects. I feel like those are separate concerns. And, like, the emulator state generally should be a simpler object than that. Yeah. The video memory size, that's what I was looking at here. I just look at, yeah, VRAM length. Nice. In fact, actually, is there a WRAM? Yeah, there's a WRAM size. Let's use the constants just because we have them. What's Aldrin? How's it going? And I'm guessing these aren't available because we need to pull in the right stuff here. The VIP should have worked, but it might just be that that's not public. This might actually come from the memory map here. And that would make sense. So I need... Up here, I need... VIP star and VIP memory map star. And that's probably why that was called length in that case. What? Oh, it's called memmap. And it's private. Now you should see that it got pointers for these, and these lengths look correct as well. 16 megs of save RAM, 256K of video memory, and 65K or 64K of system memory. That's definitely correct. Now, I really hope it doesn't try to do like save states for this or something. That'd be bad. If it tried to do that. But I wouldn't expect that it would. Anyway. Yeah, the last thing I want to do is I do want to make those data pointers private and do getters for those. Because we're only going to call the getter one time. And it'll discourage their use how I want to, so... I'll just stick it at the top here. I mean, it has to be in mute self, actually. Yeah, cheats might work. that. And then we'll get the bytes pointer for WRAM and SRAM. Here, I'm going to put this after load. Actually, I won't. Oh, that's fine. So that way it keeps load and save together. Oh, I didn't make them public. That's probably why that thought it was never used. That should be fine. I'm guessing there's an as mute ref here. Or as ref mute, I don't know. We're about to find out. Is it as ref mute? I'm guessing it is. I'm guessing it is. No, it doesn't have that. So wait a second here then. So the issue here oh, as mute. It's just called. Because we have option of T, which is our system. And if we did unwrap on that, then we would take ownership of T, and we don't want that. We just want a reference to it. So we're going to call as mute on the option. So instead of an option of T, it gives an option of mutable reference to T. And then we do all of our indexing off of that again. So the thing that this is still kind of bad about is that it does suddenly mean that there's another entity that can make changes to these bits of memory that Rust has no idea about. That's why this is not safe. But practically speaking, it's fine, and it is, I think, the correct way to implement this interface. So I think that's fine. That was the wrong one. This window. So now that's done, and that's done. It's been a little over an hour. It's pretty cool. I think the next things I want to cover is this. And then this. But I don't think I'll do either today. I think I'll actually call it quits for today because we made good progress. I feel good about this. So yeah, I'll do that. Now again, I've pushed everything here, but I'm still keeping it on its own branch. And that's just because before I fix up the command line front end, I don't want to merge this, or I don't want this on master because it won't build. And then we'll do that basically when everything's done. Anyway, yeah, I'm going to head out. Thanks guys for hanging out, and I'll see you next time.